Okay, so we are starting chapter 7, lesson 2. So your vocab notebook needs to be open to a new clean page. At the top, you need to write, oops, you don't have to write science because we're in the science section, sorry. Chapter 7, lesson 2. Earth and moon, and then today's date, March 29th, 2021, and we are starting with number 1. Don't worry about that right now, just leave it. You don't, that's not important right now, okay? So just get out your science book and your vocab notebook. Open your vocab notebook to the first clean page in the science section. Make sure that you're not just going to a random page. Make sure you're going to the first clean page. So you just finished lesson 1, chapter 7, lesson 1. The next page should be chapter 7, lesson 2, Earth and Moon. And your science book should be open to page 388. Page 388. Come on, just get out your science book. It's okay. You don't need your math book right now. Just leave it. So on page 368, we see that our next lesson is called Earth and Moon. So we're going to be learning all about the moon. Last lesson was all about the sun and how the Earth's movement in space creates day and night and seasons. Well, now we're going to be talking about what happens with the Earth and the moon. What does the Earth do to the moon, if anything? What does the moon do to the Earth? So right now, I'm going to read the look and wonder. That means you listen. We're on page 368. That means you listen and you think about what I'm saying as I read. When the moon is full, like last night, if anybody saw it, you can see shadowy places on its surface. Those shadows are really large holes or craters. How did the moon get those features? Why are the craters different sizes? Well, you can see them on this picture of moon. Those dark spots, those are these craters, these large holes in the moon's surface. We actually have them here on Earth too, in different places. Okay, go ahead and turn the page. Remember, we're going to read maybe about 1, maybe 2 paragraphs at a time. And I will start with the main idea. So find the main idea on that little bookmark in the top left corner and read along with me as I read out loud. Use your finger to follow along. Main idea. The moon's surface is rocky and covered with craters. As the moon revolves around Earth, we observe its phases. Huh? What are phases? Well, let's keep reading and we'll find out. Okay. Read next, Lena, loud and slow.
What is the moon like? On many nights, the moon appears to be the largest, brightest object in the sky. Unlike stars, however, the moon does not make its own light. Why does the moon shine? It reflects the light of the sun. Moonlight is reflected sunlight.
So, somebody said this in our last chapter. I can't remember who it was. But the light we see on the moon is not coming from the moon. Like, we can imagine the sun like a light bulb. The light is coming from the sun. But the moon is not like a light bulb. There's nothing on the moon that causes light, like the sun. Like the sun we know is a big burning ball of gases, burning gases. Well, the moon is just a rocky surface. Do rocks work like lights? If you're in a dark room, can you get a rock out and then the rock creates light that now you can see? No. But what if you put a rock near a lamp? Then, does it look like the rock has light? Yes. The moon works the same way. When we can see the moon, it's because the sun is shining on it, not because there's actual light coming from the moon. but the sun is shining on it. Just like, we're not talking about electricity, but if you go in the forest, is there anything in the forest that causes light? Nobody's there. You don't have a flashlight. There's no electricity. Is there anything out in the forest or the desert that causes light unless you have a light bulb with electricity or a flashlight? No. But you can still see. If it's daytime in the desert, you can still see, right? You don't need a flashlight. That's because the sun is shining on it. Same thing with the moon. The only reason we can see the moon is because the sun is shining on it. So what if the sun wasn't shining on it? Would we be able to see the moon? Are there some nights where we can't see the moon? Even though they're cloudy and clear? I mean, they're not cloudy and they're completely clear and you can see all the stars? I wonder why. Does that mean it's gone? Does that mean it's somewhere else in the sky where like we can't see it, like it's below Earth or something? I wonder what that means. We'll find out in this lesson. So let's look at this diagram on the bottom of page 370. This is showing us what Lena just read to us. You can see the sun, and you can see that it's shining on Earth. We have those yellow and orange arrows that show the path of sunlight. When we think of the moon, we kind of think of it like this. Here's the sun. Here's Earth. Here's the moon. But that's not what it's like. Because if the moon was here, would the sun be able to shine on it? Is Earth bigger or smaller than the moon? Class? Bigger. So if the moon was right here, immediately like parallel with us, the Earth would be blocking the moon. We wouldn't be able to see it. But you can see by the diagram on the bottom of page 370 that the moon is actually more like, oops, I made it real big. Here. So the sun is still able to shine on it, which means that we can see it. Do you see? And sometimes the sun shines on it so brightly that the moon almost creates light on Earth. But is it light coming directly from the moon? Like coming out of the moon? No, it's shining there, and then we are seeing the sun's light on the moon. Quickly, Ethan.
Why is the moon smiling?
Because that's just how it is. That's how God created it. That's just how it is. Huh? Well, we see a man on the moon, but it's not actually a man on the moon. It's just craters that look like a face. Yes, quickly. Quickly.
Aren't there like anything that like makes like a rock?
Yes, but it's usually not the rock itself. Sometimes there are certain organisms that have something called bioluminescence that makes it light. Carla, quickly.
Whenever it's daytime, I noticed this, but whenever it's daytime, you can see the moon.
Sometimes you can, and I think we learn a little bit about that in this, but we might not. That might be something you learn later. I can't remember. But yes, sometimes you can see it a little bit during the day. That's just because of where the moon is in the sky. It's usually kind of in the morning or in the later afternoon. That's because it's moving. Well, yes, the moon is moving to where we are, more closely to where we are.
Okay.
Okay, so we see on this diagram, we see the sunlight striking the surface of the Earth with those yellow arrows, those smaller yellow arrows, while also striking the surface of the moon up here. While also striking the surface of the moon, which then we can see from Earth. Okay, Lena, go ahead and read next.
The moon and Earth. The moon is Earth's closet.
Not closet. Cover up the T.
Closest.
There you go.
Closest neighbor in space. It is about 3,008.
Nope. Remember, read what comes before the comma. What number comes before the comma? Cover up everything after the comma. And what is that number?
380.
Do we say 384? And then we get to the comma and we say the name of the period, which in this case is 1,000. And then if there's a bunch of zeros after, do we say 000? No, we just don't say anything. So go try again.
384,000 kilometers. 240,000 miles from Earth. This is almost 400 times closer to Earth than the Sun.
So, what's the closest heavenly body to Earth? Mason, the moon. How much closer is the moon than the sun? How much closer is the moon to Earth than the sun? Smith.
400 times closer.
400 times closer. Very good. Okay, thank you, Lena. Read next. Victoria, loud and slow. A little louder.
Rocks on the moon are similar to some Earth rocks. However, there are many differences between Earth and the moon. For one, the moon is much smaller than Earth. There is no air or atmosphere. It has almost no water either.
Sorry, make sure your camera's on. So, how are Earth and the moon similar? Based on what Victoria just read, how are the Earth and the moon similar? Aaron.
Rocks on the moon are similar to some rocks.
Rocks on the moon are similar to some rocks on Earth. So our rocks are very similar. Our types of rocks, we have some of the same kind of stone or rock. How are they different? How is the Earth and moon different? Zadie, tell me one way the Earth and the moon are different. Make sure you're listening to Zadie's one way so that if you have another way, you can tell us what it is without repeating.
The Earth is bigger than the moon.
The Earth is bigger than the moon?
Hemispheres.
Yes. I know. I think the computer's okay, but thank you, though. So the Earth is bigger than the moon. How else are they different? Carla.
Another way that they are different is because the Earth have places where we can live, and the moon doesn't.
Okay.
It's hard for plants to live.
So the Earth, people and animals and plants are able to live on. Why can we not live on the moon? Colin, tell me one reason we can't live on the moon.
Because the moon really doesn't have any water.
There's not much water, if any, on the moon. What's another reason we can't live on the moon? Kingston. I'm asking a different question now because we already have both reasons. But why else can we not live on the moon? Michaela.
There's no air.
There's no air. And last but not least, why can we not live on the moon? There's one more reason we can't live on the moon. Zari?
There is no food.
Well, because there's no, Michaela said there's no air. Colin said that there's little to no water, and there's one other thing that they don't have. What is that, Zari?
Gravity.
Not gravity. Smith?
An atmosphere.
They have no atmosphere. Okay, that means there's no layers of air between the surface of the moon and space like there are here. You know, remember we learned about it with weather. There's like the troposphere and the mesosphere and all those. There isn't anything like that on the moon. It's just the surface of the moon and then pretty much space. Hey, Victoria, keep reading. Loud, 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 like before.
Because of these factors, the moon has an extreme range of temperatures.
Remember, a range means it starts here, it ends here, and everything between that is the range.
In the daytime, it is hot enough to boil water. The nights are colder than any place on Earth. No wonder the moon does not support life.
So now reasons why people cannot live on the moon. What are those 2 more reasons? Lena.
It's way too hot in the daytime.
It's way too hot in the daytime. Water boils at like, oh gosh, I can't remember right now what it is. I think it's like 212 degrees Fahrenheit or something like that. If you put your hand in a pot of boiling water, what's going to happen? If you've ever touched boiling water in your life, what is going to happen? Cullen?
You're going to burn your hand.
You are going to burn your hand. If your whole body is in a temperature like that, what is going to happen to you? Class.
Your body's going to burn.
It will burn, you will die. Why else can people not live on the moon? Victoria.
Because at nighttime, it is the coldest place in the whole universe.
Well, not the coldest place on the universe, but colder than any place on Earth. That means even the coldest place on Earth, it is colder on the moon at night. So that means we think it's weird when the morning starts at like 42 degrees and then it gets up to like 70 degrees in the afternoon. That's like a 30-degree range. Well, here we have hundreds and hundreds of degrees of a range every single day. So at night, it might be negative 112 degrees Fahrenheit. That means 112 degrees below freezing. And then during the day, it goes up to like 240 degrees Fahrenheit. That's like a 300-degree difference every single day. Yes, Zadie, quickly.
When people go to the moon, how do they, I know they're wearing like the suits and stuff so they can breathe, but
Those suits are like they're made out of material that can withstand the hottest of temperatures and the coldest of temperatures. So the material that it's made out of, it's not just like regular like this. It's like special materials that can withstand those temperatures. Like, I think sometimes it's made out of the same thing that we make like pots and pans out of, but like as a fabric. It's crazy. You can look into it. There's so much about it. But yeah, so they make it out of a material that's able to withstand that. Okay, so now we know several reasons why we cannot live on the moon. Carla, read next, loud and slow.
Surface features. The moon has few tall mountains.
Oh! No, actually keep reading. Keep that in mind though.
It can also have a flat plain.
Make sure you're not adding words, okay? Make sure you're only reading the words that are there. Use your finger to help you.
It also has flat plants. But most of its surface is covered with craters. A crater is a hollow area or pit in the ground.
Pause. What's our first vocab word, Carla?
Our first vocab word is crater.
Crater. Remember, if you can't see up here, it's in your book. And what is a crater, Carla?
A crater is a hollow area or a pit in the ground.
A hollow area or a pit in the ground. So not like a valley, it's more like kind of circular or oval. It's as if somebody took, I don't know, I'm trying to think of something. It's as if somebody, like the earth, like think about if you are at the beach and the sand is kind of wet and you like dig a hole. There's like an ending to that hole, right? You don't just dig across the whole beach from coast to coast and then say, hey, it's a valley or a trench. Like, no, it's a hole. It has edges. That's what a crater is. It has edges, whereas a valley doesn't really have edges. So it's different from a valley or something like that. Okay, Carla, when you're finished writing, please continue reading.
Large rocks called
Meteoroids.
meteoroids are made of many
Oh, you're adding words. That's changing. They're not made of anything.
meteors.
Meteoroids.
Meteoroids made many of the moon craters.
Meteoroids.
Meteoroids travel through space. They often crash into other space objects.
Good. So let's add the word meteoroids. And I'm going to give you the definition because we're going to add a little more. Meteoroids. Make sure you're spelling it right because that is in your book. Meteoroids. 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 They are large rocks in space. So we wouldn't go on a walk and find a large rock and call it a meteoroid, because a meteoroid is not just a large rock, it's a large rock that is in space. And they sometimes fall and they hit the moon's surface or the Earth's surface or another meteoroid. Okay, Carla, did you write that? If we have to, then you'll have to go home and rewatch every video and write if you don't do it during school, because you have to have these. Otherwise, you have nothing to help you on your test or your homework or anything. Yes, quickly.
Meteor, so the ring around Saturn? Yeah, it's Saturn. Those are actually meteors.
Not quite, because meteoroids, they're traveling in space. So those large rocks, so Victoria said the large rocks in Saturn's ring, they're large ice chunks. They're in Saturn's rings. So meteoroids are large rocks in space. Yes, Saturn is in space, but those large rocks are in Saturn. It's like large rocks that are on Earth. Well, the Earth is in space, but they're like traveling through space. In the process of traveling through space. If they are still on another planet, they're not a meteoroid, they're just a large rock. Okay, does that make sense? Okay. That was a good question. So then we don't think, oh, Saturn's rings is made of meteoroids, but it's not. Mason, did you have a quick question?
Are comets the same as meteoroids?
We're going to learn about that. They have something to do with each other, and they're not quite the same, but they do have a lot to do with each other. Okay, Zari, please read next. So hold that thought. I can't remember if it's this lesson, but it is in this chapter. It might be in this. Actually, I think it's in the next paragraph. Zari, go ahead and read.
Craters in Earth's atmosphere. If meteoroids are always crashing into everything, why isn't Earth covered in craters? Earth's atmosphere keeps them away. When meteoroids enter Earth's atmosphere, they become very hot. Most of them burn up before they hit Earth's surface.
It's the next lesson. It is. I knew we talked about it. I thought it's the next lesson. So yeah, we'll hold that thought until next week.
What was the question?
Our comets, meteoroids. They are not, but they do have to do with each other, and we'll learn about that in the next lesson. So good. Meteoroids are always traveling through space. So why are we not constantly why are we not constantly being hit by meteoroids? They're always traveling through space. There are always meteoroids, large rocks traveling through space up there. Why are we not? And they do crash into other objects. But why are we not being hit by them constantly? Why is that not a thing that we have to worry about every time we go outside? Aaron.
Because when they hit Earth's atmosphere, they usually just burn up and disappear before they hit the ground.
Good. So here's Earth. And we know we have those several layers of air above us. We have like the troposphere, and then the mesosphere, and I can't remember. We have like several different layers of atmosphere. Those are those layers of air around the Earth's surface, right? And here's space. And the moon, with the man in the moon. That's just how I'm going to show that it's the moon. It has the man in the moon. So, all of a sudden, here is a meteoroid, and it's coming straight towards Earth. Well, it starts here, and it's a little smaller, and it's on fire. And then it keeps coming, and it's like teeny tiny. Let's see. And it's still on fire. And then it just burns up. Like imagine if you put a block of wood in a fire. Is it still a block of wood after you've burned it for like a few hours? What is it? Mason? It's just dust. It's ash. That's the same thing with the meteoroids. As they enter Earth's atmosphere, they start to burn up. Remember, as things burn, they get smaller and smaller and smaller until they're just like ash or dust. And is it going to hurt the Earth if a piece of dust hits it? No. And usually even then, if you keep burning it forever and ever and ever, eventually even the ash and the dust is going to completely burn up and burn away. Smith, what's your question?
Is that how we end up with small rocks on Earth?
Sometimes. Not all small rocks, but some. Okay, we have to move on because I want to get through this next page so that we can do this for morning work. We can do the guided independent practice on this for morning work tomorrow. Okay? Okay. What are the phases of the moon? Please read. Mason.
What are the phases of the moon? Like the sun, the moon seems to rise and set. The sun does not move around the Earth, but the moon does.
Oh, sorry. So remember, does the sun move? No. What moves? Class. Earth. Well, the moon appears to move, and the moon does move. The moon revolves around us. We revolve around the sun. The moon revolves around us. Keep going, Mason.
As Earth revolves around the sun, the moon revolves around Earth.
So, this is going to be a difficult, I don't think we have enough space this year. Mason, can you come up here and be the Earth? Kingston, come be the sun. Just leave that on. You're fine. Come on, quick, quick, quick. Does the sun move? Does the sun move? So are you going to move? Nope. You're going to stand right here, and you're not going to move. You're the Earth. So how are you going to move around Kingston? But like how? In what shape?
This?
Just like a circle, right? Well, I'm going to be the moon, so you need to actually like do a lot. So I'm going to be walking around you while you walk around Kingston. Can you do it? Okay. So just keep going. Just keep walking. I'll try to stay out of your way. Ooh! There you are. We don't have much space. It's not really working because we don't have enough space. But we try. Go ahead. But I try. We just don't have enough space. We need like a big room. But as Mason, the Earth, is going around the sun, I, the moon, am trying to move around Mason. But we just didn't have enough space, so it wasn't working well. Yes?
Couldn't we do it in the hallway?
Maybe, but then Zari can't see. Well, but then we wouldn't have time to finish this before we need to pack up in like 10 minutes. Okay? So, as the sun is moving around this, as the Earth is moving around the sun, the moon is moving around the Earth. Keep going. It completes.
It completes one orbit around Earth in just over 29 days. This is almost as long as an average month. In fact, some of the earliest calendars were based on the moon's motion.
So, let's make ourselves some notes. How long does it take for the Earth to orbit around the sun? That means to make one full orbit around the whole sun. Lena.
24 hours.
Not 24 hours. That's a rotation. That's how long it takes for it to spin. How long does it take Earth to orbit around the sun? So remember the difference, Lena. The rotation is 24 hours. That's how long it takes to just spin in place. But the orbit is how long it takes for it to go around the sun. How long is that? Michaela.
Over 29 days.
Nope. How long does it take for the Earth to orbit around the sun? Mason.
29 days.
Nope. Carla.
It takes the Earth orbits around the sun take 365 days or 1 year.
365 days, which Carla told us is the same as 1 year. I did not ask, how long does it take for the moon to orbit around the Earth? I asked, how long does it take the Earth to orbit around the sun? That's 365 days, a year. That's why we have a year. Now, how long does it take the moon to orbit around the Earth? How long does it take the moon to orbit around the Earth? Victoria. About 29 days. Which is about as long as what, Victoria? About as long as 1 month. Not exactly 1 month, but about as long. So that means it takes about a month for the moon to make it. Here's the Earth. From here, all the way back to there. Yes, Zadie.
And today's the 29th.
Today is the 29th. But because it takes about 29 days, sometimes it happens at different times throughout the month. However, this month, it did kind of work out that we had our full moon on right at the 29th. So it kind of worked out. Okay. That's important to know. Smith, read next.
Apparent shapes. As the moon orbits Earth, its appearance seems to change. The apparent shapes of the moon in the sky are called phases.
Okay, what's our next word?
Phases.
Phases. And what are phases, Smith?
Apparent shapes of the moon in the sky.
Apparent shapes of the moon. Notice how moon is capitalized because we're talking about a specific moon, our moon. Apparent shapes of the moon in the sky. We have that word apparent, which means how it seems to look, but is that actually how it looks? If something has an apparent shape, is that the actual shape, or is that just what the shape looks like? Aaron? It's what the shape looks like. So does the moon change shape as it moves? No. It is always shaped like a ball, a sphere. It just looks different as it moves through the sky. Keep reading, Smith.
During one complete orbit, the moon cycles through all of its phases. At the same time, the moon completes about one rotation.
So, as it's moving through the sky, those 29 days, we see all of those shapes. Does the moon change into all those shapes? No, we just see all of those shapes, and it finishes one orbit. Keep going.
All this time, the sun is shining. It lights one half of the moon at a time. The other half is dark. During the moon's orbits, we see different fractions of its lightened half.
So, we're going to look at this diagram now. Pay close attention. But first, yes. Zadie, turn off the lights. And then come hold this flashlight. We're going to see, what does that mean? Smith said that the sun only lights one side of the moon at a time. So be the sun. And here's our moon. The front of the moon is lit. What about the back of the moon?
No.
Is it lit? No, because where's the sun shining at it? Here. Is the sun shining back here?
No.
No. So here we have the lighted side of the moon. But there's other things. It doesn't just look full no matter what. Thank you. Go ahead and turn the lights back on, and then you can take that. It doesn't look full no matter what. So let's look at this diagram to see those different apparent shapes. We're going to start with the new moon. So everybody find the new moon on page 372 and put your finger or your pencil on it. Find the new moon on page 372 and put your finger or your pencil on it. So what that means is that the lighted side of the moon cannot be seen from Earth. Sorry, I do need you to come back. So remember, as the moon, as I am revolving around the sun, the moon is revolving around me. So when it's a new moon, I'm the Earth. This is the moon. The sun is where Zadie is. Can you come a little closer so we can see you in the video? Okay, stop. The sun is where Zadie is. I, the Earth, am here. Can I see the light side of the moon? No. I'm behind the moon. The moon is between me and the sun right now in its orbit, right? So I can't see it. So now we have the new moon. The lighted side cannot be seen from Earth. Next, we go to, so follow the line of that arrow. The arrow is going counterclockwise. That means it's going opposite of the clock. Yes. We have the waxing crescent moon, which means some of the lighted side can be seen. So here I am. Ooh, gosh, that's bright. Shine it, yeah. Shine it. I'm starting to be able to see just a little bit. It's about right here. So find the waxing crescent moon. Don't worry about that. You really need to worry about following along with the diagram right now, please. Thank you. I appreciate you trying, but let's worry about this right now, okay? So see, it's moving. New moon, it's here, between me and the sun. I can't see it. But it's starting to move, and now it's a circle. This is not a ball. I don't have a tennis ball or anything. So I can start to see a little bit of it. And you can see some of the lighted sign can be seen in the waxing crescent moon. Then we have the first quarter moon, which is right here. I can see about half of it. The moon is a quarter of the way around Earth. That's what we would call a half moon. Why are you looking over there? Is Ethan teaching our class right now? So you're not watching at all. So right now, I can see about half of it. This is where we would call it a half moon. Do you see how me and the moon are kind of parallel to each other? Then we have the waxing gibbous moon, which means I can see a little more of it. I still can't see the whole lighted side, but I can see almost the whole thing. Then we have the full moon, which means I can see the whole lighted side. I am between the sun and the moon. Then we start to see less and less of it, because then it's here and I can see almost the whole thing, but not quite. The waning gibbous moon. I can see slightly less of the lighted side. See, this part, I can't see it from where I am. Then we have the third quarter moon. I can only see half. I can see this half of the lighted side. Then I can see even less of it because it's starting to move between me and the sun again. We have the waning crescent moon. You know, like the Cheshire Cat smile? That's what I can see right now, just a little bit. And then, 29 days later, I can't see any of the moon. It's the new moon again, because the moon has moved back between the earth and the sun. Thank you. So, those of you that were paying attention as I did that, instead of watching over there or watching the shadow or something else, you saw a demonstration of what that looks like. As it moves, I can see more and more and more. It starts with nothing at the new moon. I can't see the lighted side because it's over here. And then I start to see more and more. Who's seen The Karate Kid? Do you remember when Mr. Miyagi says wax on? If you see waxing crescent moon or waxing gibbous moon, that means more and more of the lighted side can be seen. So think of Mr. Miyagi saying wax on. I know he also says something different, but we're not going to worry about that. We're only going to think about wax on. So if you see waxing crescent moon or waxing gibbous moon, does that mean more of the lighted side is being seen or less of the lighted side is being seen? Carla?
The gibbous is...
Nope, don't read it from the book. And we're talking about gibbous. I'm saying if you see waxing crescent or waxing gibbous, is more and more of the moon being lit or less and less? Lena?
less and less.
Remember, Mr. Miyagi says wax on. That means more and more wax is going on. So if it's a waxing crescent or a waxing gibbous, are you seeing more and more or less and less of the lighted side? Zadie?
More and more.
More and more. Remember, wax on. If we turn a light on, do we see more light or less light? Class?
More.
More. So wax on means if you see waxing crescent or waxing gibbous, more and more of it is being lighted. But then, after the full moon, we start to see waning gibbous and waning crescent. To wane means to disappear. Like if you hear the light is waning, that means the light is disappearing. It's late afternoon. The light is waning, it's getting darker and darker. So if you see waning gibbous or waning crescent moon, does that mean more and more light is being shown or less and less light is being shown? Think about what I just said. What happens when the lights are waning? Can we see less and less of it or more and more of it? Zari?
Less and less of it.
Less and less. So remember, if you are trying to decide, is the moon waxing or waning? If it's waxing, you can see more and more of it, which means it's moving from, you can draw this picture, the new moon. First, we have the waxing crescent. Which means most of it is dark, but a little bit of the lighted is starting to be seen. Then we have the first quarter moon, which means we can see about half of it. Make sure you're putting the lighted side on the right side. Then we have the waxing gibbous, which means we can see almost all of it. And then we have the full moon. Yes, quickly.
Why do they call it the first quarter moon when it's in half?
Because, can we actually see half of it? When can we see half of it? When can we see a whole half of the moon? At the new moon, because we can't see the back. I'm sorry, the full moon. Because can we see the back? So that's only half. So when it looks like it's a half moon to us, that still means this half and the whole back is dark, right? So we can only see 1/4 of it, or a quarter. So we wax on. Now continue your drawing, but I don't have enough space. Well, I can start it. Then we have the full moon. Some of you are not listening, and you are really going to struggle tomorrow morning. I hear a lot of noise. I see a lot of people just looking everywhere except up here. I see some people not drawing the diagram. You're really going to struggle tomorrow. Those of you that are listening, you'll probably get 100. Those of you that are not, you're going to struggle. So then we have the full, where we can see the whole thing. Well, the whole front, not the back. Then we start to see less and less. First, we have the waning gibbous moon, where we see most of it except for that little bit. Then we see the third quarter moon, which is when we see, it looks like a half moon to us, but we actually only see 1/4 of it, the quarter. Sorry, please turn your camera on. Then we see a little less, the waning crescent, and then we see none of it at all again, and it starts all over. So we can say wane off. Mr. Miyagi says wax on, wane off. I know he actually says something different, but for this science lesson, we're going to say wax on, which means we can see more and more, and wane off, which means we can see less and less. I just talked about that for a long time. I'm not repeating myself again. Wax on, we can see more and more of the light. Wane off, we can see less and less. Okay, as soon as you're done drawing that diagram, close your science books. Keep your science books out. You have optional science vocab. If you know that your science grades tend to be a little lower, you might want to make sure you do it. Tonight is the only chance you have. So leave your science book out. You can put your vocab notebook away and get out your planners.